This video is the second part that works with ANOVA, hypothesis tests, and the ANOVA table. Chris Turlock owns and manages a small business in San Francisco, California. The business provides breakfast and brunch food via cart parked along sidewalks to people in the business district of the city. Being an experienced business person, Chris provides incentives for the 4 salespeople operating the food carts. This year, he plans to offer monetary bonuses to her salespeople based on their individual mean daily sales. Below is a chart giving a summary of the information that Chris has to work with. A sample is a collection of daily sales figures in dollars from this past year for a particular salesperson. There are 4 groups: salesperson 1, salesperson 2, salesperson 3, salesperson 4. Sample sizes are 84, 61, 77, and 132 respectively. Sample means are 202.4, 214.0, 217.0, 197.9 respectively. Finally, sample variances are 2,265.2, 2,275.5, 2,718.3, and 2,381.7 respectively. Chris performs an ANOVA to test whether or not there is a significant difference in the performances of the different salespeople. This ANOVA is summarized in the incomplete ANOVA table below. Complete the ANOVA table and then answer the questions below in the table. The table itself. Source of variation. There is a treatment between the groups, error within the groups, and total. Next column represents degrees of freedom, and they're all blank, so I need to fill in treatments, degrees of freedom, error, degrees of freedom, and total degrees of freedom. Next column represents sum of squares. Treatment sum of squares, first number, is 24,282.79. Error sum of squares is 843,135.1, and total sum of squares is 867,417 and 89/100. The next column represents mean square. First number, treatment mean square, is not known, blank. Next number, error mean square, is also unknown, blank. Finally, the last column has only one cell. That's F statistic. We need to find F statistic as well. It's not provided. Let's fill in the table first. I'm going to work on the second column where all the degrees of freedom are not provided. Please recall that K represents the number of sampled populations and uppercase N represents the total number of data entries. If you look at the table above, we know that there are 4 different samples, sales from 4 different individuals. Therefore, K is 4, and degrees of freedom for treatments, K minus 1, must be 3. The total number of data entries is found by adding the sample sizes 84, 61, 77, and 132. That yields 354, and when I take 354 and subtract 4, which is the number of sample populations, it gives me 350. Add 3 with 350, in other words, combine the treatments degrees of freedom and error degrees of freedom to get a total of 353 in the last cell of this column. Now we need to compute mean squares, treatment mean squares, and error mean squares. Treatment's mean squares is found by finding the ratio of treatment sum of squares divided by its corresponding degrees of freedom, K minus 1, and error mean squares is found by dividing error sum of squares divided by its own degrees of freedom, uppercase N minus K. So let's come back to treatment mean of squares. we need to take SSTR, which is given to be 24,282.79, and divided by the corresponding degree of freedom 3. We find all of this information in the table, of course. Take this number of 24,282.79 divided by the degrees of freedom to get treatment's mean square of 8,094.26 when rounded to 2 decimal places. Similarly, take error sum of squares 843,135.1 divide by its corresponding degree of freedom of 350, which is uppercase n minus k, and that yields 2,408 and 96 hundredths. F statistic is the last number that we need to compute, and it is found by dividing MSTR by MSE. Since we computed both of these quantities, let's find the quotient of 8,094.26 with 2,408.96, and the result is 3.36. Now that we completed the ANOVA table, we are ready to answer 2 questions. Question 1. What is the p-value corresponding to the F statistic for the ANOVA test? Round your answer to at least 3 decimal places. We have F distribution with a test statistic of 3.36. To find p-value corresponding to this F statistic means finding the area to the right of that test statistic. To answer this question, we use function f(CDF) on our calculator, where my lower bound of the interval is 3.36, upper bound is positive infinity, numerator's degree of freedom is 3, denominator's degree of freedom is 315. The resulting p-value is 19 thousandths, which means that to the right of 3.36, we have slightly less than 2% of data. Let's answer the last question of this assignment. Can we conclude, using the 10% level of significance, that at least one salesperson's mean daily sales is significantly different from that of the others? Because p-value of 19 thousandths is less than or equal to alpha of 10 hundredths, we reject null hypothesis, which states that the means are same. Because of the rejection of the null hypothesis, we can conclude that at least one salesperson's mean daily sales is significantly different from that of the others. Therefore, I am answering yes on the last part.